This is Pre-Algebra, video chapter 1, lesson 9 on estimating roots. We are going to have an objective, and our objective is, as a student, I can use roots to estimate solutions because I will use my knowledge of perfect squares and rounding. Speaking of perfect squares, in red I listed some of the ones up to 12 squared. You want to be able to recognize these are based off of your times tables, generally speaking, but you want to be able to recognize perfect squares. The faster and easier you can recognize these, the faster you'll be able to estimate solutions to different expressions and situations. And I'll show you what I mean. For example, let's say there was a problem where at some point you need to find out what was the square root of 15. Now, you'll notice 15 is not a perfect square, so if you were to take the square root of 15, it would be an irrational number. By the way, the square root of any non-perfect square is an irrational number. Irrational numbers are numbers where the decimal goes on forever without a pattern. It never stops. So you can't really do operations with that by hand because you'll have to round at some point with those decimals. So what we're going to do is this. If we, for the sake of at least finding an answer and estimating it, this is what we're going to do. Now you'll notice, square root of 15. 15 is really close to 16. Well, 16 is 4 squared. This is just under that. So that means we're going to say approximately 3.9, maybe a little less than 4. That's what this is going to be. That's what I mean by rounding and estimating based off of knowing your knowledge of perfect squares and then rounding based off of who is it closer to and trying to get an idea of what the decimal might be. And by the way, if you were to legit use a calculator to check, it would be 3.8729833346. I'm not going to keep saying that. I'll die. It never ends. So round it to about 3.9. So my estimation was on the spot. So do that same thing to help you. So for example, let's try this one first. If we had the square root of 62, what do you think that would be? Now, you'll notice 62 is pretty close to 64, but not quite there. 64 is 8 squared. 62, okay, it's way closer to 64 than it is to 49. So this one might be a little less than 8, maybe 7.9, 7.8, somewhere in there. So I'm going to call this one 7.9 again. Now, I didn't mean to do that on purpose, but yeah, that way it's probably going to be 7.9. Let's check it with the calculator. Alright, so that one was 7.9. Now let's try one that's kind of in the middle of the road, like square root of, let's say, 54. Now, square root of 54, that's kind of somewhere in the middle of 49 and 64, but if you actually check, it's 5 more than 49, but it's 10 less than 64. So that means it's closer to 49 than it is to 64. So it's almost like a third of the way through, a third of the way in that path. Well, speaking of a third of the way, that would be about 0.33, so it's somewhere between 7 and 8, maybe about 7.33. So for that reason, I'm going to say about round down, so I'm going to say about 7.3. Now let's check it with a calculator. Now to make that legit with a calculator, it's 7.3484, it keeps going. But essentially, it rounds to 7.3, so that was a good estimation. But use that when you're doing these, is get an idea, is it a little more than halfway, is it a little less than halfway? If it's about halfway, just say like 7.5. But if it's a little less than halfway, maybe 7.4 or 7.3. And this way you can make quick, snap judgments on your own. But if necessary, yeah, you can use a calculator to check these more exactly. But I wanted you to know what I meant by estimating and rounding, where right off the top of your head, if you recognize your perfect squares, we want to practice this skill so you can already kind of have a ballpark figure of what kind of answer you're expecting. Now, I went ahead and listed those perfect squares again just so that we're used to noticing them. Now, for the sake of keeping it simple, it seems like most of what we're doing in pre-algebra is mostly going to be rounding to the nearest whole number, to the nearest integer. So that's what we're primarily going to focus on. I just want to make a point that you could do it with decimals if necessary. So let's say, for example, you were asked to find, it would say rounding to the nearest whole number. What is the square root of 118? Now, you'd be like, okay, let me look at my list of perfect squares. That's somewhere between 100 and 121. It's definitely closer to 121. So for that reason, we're going to say it's about 11. If we're rounding to the nearest whole number, it's nearest integer. It's definitely closer to 121 than it is to 100. And so that's what it's going to be. Now, if you wanted to check this, like I said, legit with the calculator, you would get 10.86. Well, that still is going to round up to 11, so you're right on spot point. Now, as a side note, the same thing goes if it was asking for about perfect cubes or cube roots. So when I listed out some perfect cubes, I don't necessarily expect you to memorize these. These aren't as commonly used, but maybe just be comfortable finding them on your own with the calculator if you needed to. So let's say we were asked to find what is the cubic root of 320 rounded to the nearest integer. Now if you look at your list, 320 is a lot closer to 343 than it is to 216. So that means it's going to be a lot closer to 7, so it means it's going to be approximately 7. And if you were to check with the legitimate answer, you would get 6.839, and that to the nearest whole number, that would round to 7. So let's say you were going to solve an equation or solve a situation, but you wanted to estimate your answer. Maybe you wanted to predict or find a ballpark, or maybe you didn't have a calculator handy. So we're going to estimate the solution of each equation to the nearest integer. If you have y squared equals 75 and you're asked to solve for y, that means you're going to have to get rid of that squared, so you're going to have to square root both sides. So the square root and the square cancel out, and you're left with y equals, now estimating the square root of 75. Let's see, 75, that's between 64 and 81. Now it's definitely closer to 81, so that means it's going to be closer to approximately equal to 9. So that tells us 9 is approximately the solution to this. So let's say we were given a cube, and we know the volume of the cube. Let's say the volume of this cube is 260 cubic inches. And now the instruction said, or our goal was, to estimate the side length to the nearest integer. So this, when we say the side length, we're referring to this length right here. And if it's a cube, these three side lengths will all be the same. Because it's a cube, that's the whole point. So solve for it. Now, if you didn't already know it, the equation for the volume of a cube is volume equals side length cubed, or side length to the third power. By the way, that's where the exponent of 3 got its name, got its nickname of cubed, because that's how we find the volume of a cube. So anyways, so if we know the volume is 260, we can kind of plug it into V spot. So we would have 260 equals s cubed. Now our job is to solve for s. So in order to do that, we have to get rid of the cubes. So the opposite of that is a cube root. So we need to cube root both sides. So on the right side, the cube root and the cube cancel out. So on the right side, we're left with just s, or side. Now on the left side, we need to estimate the cube root of 260. Now, that would be easy if you had your handy-dandy list of perfect cubes readily available. We have 216 and 343, so 260 is right in the middle of those. It's 83 away from 70, and it's 44 away from 216. So it's definitely closer to 216 than it is to 343, which tells us it's going to be approximately equal to 6. Now, 6 inches, since we're talking unit of measure. Now, if you were to legit check with the calculator, you get 6.38, so which would round to about 6. So that means the side length of this cube is about 6 inches. So this is another thing you can use estimating for. Now what I'm going to do is I'm going to give you a few examples to try on your own, and then you're going to hit pause, try them, and then hit play, check yourself, and then we're all done. So this is going to be a short video. Alright, so I've got 4 questions on the screen that I want you to solve. The 4th question is just the cube, by the way. I want you to find the side length, just like we did in our example. So I want you to find the roots of each of these and round them to the nearest whole number, the nearest integer is what I want you to do. So press pause, try these on your own, and press play and see how you did. Okay, so 152, well that's between 144 and 169. And it's definitely closer to 144, so that means that's going to be approximately 12 is what that's going to be. And then 28.2, sure, it's a decimal, but remember, we're rounding to the nearest whole number anyways, so that sounds like that's between 25 and 36 as far as perfect squares are concerned, so right in here. So that one's going to be closer to 25, which means it's going to be approximately 5. It's going to be closer to 5 than it is to 6. Now, cubic root of 62. I'm going to refer back to my mental list of those, and I see that 62 is really close to 64, definitely closer to 64 than 27. So that tells me the square root of 62 is going to be 4. So you've now found each of those. Now if you haven't tried this last one, the cubed box, then do that now. And if you need a reminder, the volume formula is volume equals side cubed. You're looking for the side length. So we're going to plug in for that. So 500 equals side cubed. And then we're going to solve for s. So we have to do the cubic root to cancel that out. So the cubic root and the cube cancel. We're left with just s on the right side. And now we're rounding to the nearest whole number. On the left side, cubic root of 500. We're going to check that list. That's really close to 512. Definitely closer than it is to 343, which tells us it's going to be approximately 8. So 8 centimeters. That is the side length of this cube. So I hope you did well. Make sure you have everything written down. Feel free to rewind and to write down each of the examples if you still need to. I'll see you guys in class.